So this is our cryptography learning platform for Discrete Structures 2 project. So here is our encryption panel or button. So you click it, you select which encryption, and you can learn um, information about encryption here. So this is what is encryption. It is the process of converting information or data to prevent unauthorized access. And this way is encryption important. Types of encryption like symmetric, which has key, and asymmetric, which has public and private keys. So symmetric encryption is Caesar cipher or Vigenère cipher, and our asymmetric encryption, which has public and private key, is RSA. So let's try RSA here. So you enter a prime number, and also you can see information about RSA here. How does it work? Why use RSA? And what is RSA encryption? So let's use a prime number 11, and then our other prime number for Q is 13, and enter message. Let's try text. We generate the steps. So step 1 is to compute the n, which equals to p times q, and our p is 11 and q is 13, so 11 times 13. And then you have the Euler's n, which is p minus 1 and times q minus 1, and it equals to 120. We select public key 7, which is our hard coded in the program, and the private key 103, or the modular inverse of E mod ng Euler's n. So this is the steps. You convert the message letters to numbers. So T is 19, E is 4, X is 23, and T is 19. Then you encrypt it. M equals 19. Now the encrypted M or encrypted T is now 46. Encrypted E is 82. Encrypted X 23, and T 46. Then you got your encrypted message here, which is 46, 82, 23, and 46. Then we proceed to decrypt it. So encrypt T 46, T raised to the power of 103, mod 143 equals to 19, which is T. Then so on and so forth. You go here, and then you get the decrypted message, which is text. Now let's go back here, back to encryption. Now let's try our Caesar cipher. You input your plain text here and ciphertext here for decryption. Now we have explanation about Caesar cipher here. Caesar cipher is a substitution cipher that shifts each letter in the plain text by fixed number. So it shifts down the alphabet. So here, if you shift with 3, A will become D, B into E, and C will become F. And decryption, the same. So D will become A, E equal become B, F equals C. Now we have a step-by-step visualization here, so let's try. So same, we go text, then we shift it by 3. So this is the encrypted text here, and the original plain text. So shift value 3, encrypt T. So this is the calculations, 84 minus 65 plus 3. Then it will become H, E, X equal A, T will become W. So you got the encrypted text. Wow. Then we decrypt it. We copy the encrypted text to the ciphertext input field. Then we input the shift value, so 3, and decrypt it. So this is the decrypted text. H, A, and W. So this is the decrypted text here, text. Now let's try again the Vigenère cipher. So Vigenère cipher, it's a method of encrypting alphabetic text by using a series of interwoven Caesar ciphers based on the letter of a keyword. Uh, each letter of plain text is shifted along the alphabet by an amount determined by the corresponding of the repeating word. So this is the encryption formula, where P is the plain text, K is the key letter, and C is the cipher text. And then this is the decryption formula, which C cipher text, same as the encryption formula. So let's try it. And plain text is text again. Then the key. So take note that the key text must have the same amount of letters as the plain text. So let's try A, B, C, D. Then we encrypt it. So this is the encrypted plain text, the cipher text, T, F, Z, W. And this is the encryption formula. Encrypt A with KB, encrypt X with KC, encrypt T with KD, and this encrypted text or the cipher text is TFZW. Then we decrypt it, and the cipher text is text. So same, encrypt A with A, B. So let's go back here. So since we have done all the encryption, let's try the combinatorics. This is our page for combinatorics concepts, which includes permutation, combination, binomial theorem, pigeonhole principle, graph theory, and the application of combinatorics. Then the users can also test themselves here with a multiple choice uh, answers and a decryption, um, decrypt the cipher text with evil with the shift to 3. So it's only up to 20. Then you can submit your answer here. Psi shift. Um, just run through it. So if you submit it, you get 2 out of 20. Then you can try again, and then the questions will change. So we have made it dynamic for users, so they can just answer the same questions again and again. The questions on are up to 50 questions here that will be put into the user test page. Only up to 20, but it is randomized. So this is all for our discrete structures 2 program.